This is a different problem. It's a cheese manufacturing company. We know that this cheese product can only be kept for 1 week, and anything unsold at the end of the week will have to be, they can't sell it at full price. The demand distribution is discrete again. So we have 10, 11, 12, 13, or 14 cases that we could sell each week. The probabilities are given to us. We know that the cost for 1 case of cheese is 75. We know our selling price, full selling price, is $100. And we know that if at the end of the week we are unable to sell a case of cheese, that we can salvage it and sell it to a local food processor. So the salvage value that at the end of the week we can, the money that we can get for it is how much? $50. So remember step 1 in marginal analysis. This is again a single period inventory item because it has limited life that we can keep it on hand. And so we must do marginal analysis. And step 1 is to identify what is the marginal loss, which in this case is the cost to buy a case minus the $50, which we can sell it to the food processor as a salvage value. So the marginal loss is 25. Marginal profit is the profit that we would have made if we had enough to sell. So that would be the selling price minus the cost of $75. So that's $25. I'm sorry, this is not step 2. We're still doing step 1 when we compute marginal loss and marginal profit. Step 2 is to compute the critical probability, which is marginal loss divided by marginal loss plus marginal profit. In this case, both the marginal loss and marginal profit are the same, are equal to each other. So this critical probability will be 0.5. The third step is to compute a cumulative demand distribution column. So probability that demand is greater than or equal to X is, and we must populate that column. Now we know the summation of all the probabilities must equal, for all the probability of all the values must equal to 1. So probability that demand will be greater than or equal to 10 is 1. Probability that demand will be greater than or equal to 11 will be 0.8. The next one will be 0.5, then 0.3, and then 0.1. So once we create our cumulative demand column, then we must finish the problem by placing our critical probability along this axis to see where does it fit. And the 0.5, the 0.5 exactly is equal to an entry in this column, and that belongs to this quantity. So Q star is 12. So every time that she buys cases of cheese for 1 week, she should buy 12 cases. And then if at the end of the week she's not able to sell them at the $100 price, she'll have to salvage it at $50 and sell it to the local food processor. Thank you.